The Purpose of Science Education, a podcast by Evelyn Gray. In this podcast, I will present my vision of science understanding as a product of a collaborative effort amongst educators at Michigan State University. If you eat a banana for breakfast, you will get an A on your tests. This is how Mrs. Gray begins her science classes each year. This is a simple example of situations that may occur in the lives of our students. When they're presented with this conclusion, they start wondering about the validity of the conclusion. They ask questions. Are you serious? Will that really work? They're going to want to research their questions because they don't believe it. They're going to read science articles and they're going to try to understand the articles. They're going to evaluate the quality of the articles. They really want to find an explanation to know if it's really true, if they should start eating bananas. When it's all done, they will argue with evidence they have collected against Mrs. Gray's conclusion. According to NSTA, these are the goals of science education. In a position statement, the National Science Teachers Association described these as goals of scientifically literate person. Each can be used with my example of a banana. Now, that may be a simple and outlandish conclusion, but it gets students thinking about what you can believe and what you can't, and about other instances when they have come across a statement they weren't sure was true. We want our students to recognize and be able to respond to such assertions. The Next Generation Science Standards provides standards to help reach these goals of scientific literacy. On the left is the list of goals by NSTA. On the right, the Next Generation Science Standards. The disciplinary core ideas and the cross-cutting concepts of the Next Generation Science Standards provides guidelines for content. When looking at science literacy, this portion refers to describing, explaining, and predicting natural phenomena. The rest of the science literacy goals can be found in the science and engineering practices, where they're laid out the expectations of all the other parts of science literacy. We want our students asking questions, like when they're presented with the banana scenario. We want them to carry out the investigation, look into it. Is it true or not? We want them constructing explanations and engaging in arguments using the evidence that they find. The Program for International Student Assessment, or PISA, also developed a framework for science education. They identified 4 components of science literacy. The first is knowledge, or what you know about the natural world and about science itself. These can be found in the Next Generation Science Standards under disciplinary core ideas and cross-cutting concepts. Second, competencies are identifying science issues, explaining phenomena scientifically, and using scientific evidence. These, again, refer to the science and engineering practices. The last 2, context and attitudes, are not identified in the Next Generation Science Standards, not specifically. Context is the life situations that involve science and technology, and attitudes is how you respond to those science issues. The article Teaching Science Literacy by Grant and Lapp offers suggestions on how to incorporate the context and attitude portions of science literacy. First, they recommend that you identify science topics of interest to your students. Engage your students in reading research and teach them how to read like scientists. Lastly, guide student learners to evaluate data. In the article, Grant and Lapp ask 2 critical questions. Do most students think about the effect of these issues on their everyday lives? Do our students consider the roles they might play in changing how a science-connected problem is resolved over the coming decades? Their answer? Probably not, unless they are taught to do so. At the end of the day, our students need to learn what types of concepts might have an influence on their lives and how they might influence the lives of others. I think that idea helps students to understand why they should want to be scientifically literate. The group of science educators working on this effort identified many purposes for science education and linked them to a vision of science understanding. Here are a few. We want our students to be receptive to information, keeping an open mind and allowing the input of new information regardless of bias. We want our students to make educated decisions, use skills and knowledge rooted in science to question, challenge, test, make informed decisions regarding everyday occurrences. We want our students to solve problems. In this day and age, science is going to be a big factor in how they live their future lives. Acquire skills to enter a career. Education is meant to take us to that future we can't grasp. Science understanding, to me, is having the ability to not only grasp content, but to understand how the content learned affects the learner's future. By Sir Ken Robinson. We want our students to think critically. I see science as a way or a method of thinking, and I believe that is reflected in the next generation science standards. We want our students to engage in science discussions so people no longer feel excluded by science and debates about science. Students need to realize it is not the vocabulary but the practices that are important in scientific discussions. The purpose of this presentation was to define science understanding, scientific literacy, and the purpose of science education. All three terms are one and the same. The purpose of science education is to help people understand science, which results in the teaching of tools necessary to be scientifically literate. Science is a way of thinking. Goals for science education are laid out in multiple documents. The NSTA position statement, the framework for K-12 science education, and the PISA analytical and assessment framework, all of which boil down to many similar concepts, which if taught to our K-12 students will result in scientifically literate students. Thank you very much.